Now what we're going to do is look at some graphs and try to match it up with ones that make sense. So first it says identify the strongest and weakest scatter plot. Well, obviously C makes a straight line. This is going to be our strongest. And it is a positive correlation, so that's obviously going to be at 1. So C's got to be that one. Now, our weakest, it looks like it's going to be B, because some go up, some go down, but there's really no pattern forming, so that's probably going to be our 0. Now, let's make sure the rest of these make sense based on the graph. Well, let's look at A. That one, it looks strong, and it's positive, but it's not perfect 1. It's going to be close to 1. So let's go with, 0.92. So that's going to be letter A. Now, so we've already used A, C, and B. So now let's look at D. This one's also positive, but it looks pretty weak, so it's going to be less than 0.5, or you know what, right there at 0.5, that makes sense, because that's the only positive. Now these two we've got negative. One is at negative 0.85, one's at negative 0.48. At 0.85, that's closer to negative 1, so that's going to be the stronger. That's got to be E, and so negative 0.48 has got to be F. All right, let's look at question 2. It says, which calculator output shows the strongest linear relationship? So we're looking just at the R value. We want to get the one that is the strongest. I've got, this is 0.81, this is 0.63, this is 0.89, and 0.84. Well, strongest means it's got to be close to positive 1 or negative 1. All these are positive, so which one's closer to positive 1 whole? And it is D. Number 3, which correlation coefficient of linear fit of the data below to the nearest hundredth? So we look at this data, and first off, we can see it's all going down, right? This is negative. So I can eliminate 1 and 2, because those are both positive. But on our negative, does this make a perfect line? No. There's a few up and a few down. So it's not going to be negative 0.1. It's got to be negative 0.93. Close, but not straight. All right, question 4. The relationship between the number of widgets in a package and the length of patches in inches is given at the table on the right. What is the linear coefficient for this relationship? Is it a good, not good, or perfect fit? Well, widgets and packages, widgets going up, 3, 4, 5, 6, packages going up. So that's going to be a positive correlation. I can go ahead and knock out C. Now I look and I see that each of these is going up by 0.25 every single time. So there is a clear pattern. It's definitely not D. So it's either going to be positive 1 or 0.5. Well, this increases by 0.25. This goes up by 1. This increases by 0.25. This goes up by 1. Every single time it's doing that. So that's going to be a strong relationship or a perfect one, because the slope is the same each time. Let's look at number 5 now. A nutritionist collects information about different brands of beef hot dogs. She made a table showing the number of calories and the amount of sodium in each dog. It says write the correlation coefficient line best fit, then round your answer to the nearest hundredth. Explain what the correlation coefficient suggests in the context of this problem. So this is where we're actually going to have to use it. We're not just comparing, we're actually going to have to plug it in. So I know my diagnostics on, because I left it from last time, so I'm going to go stat, edit. I'm going to type in all my values for my L1. So I got 186, 181, 176, 149, 184, 190, 158, 139. Now I'll go to my L2 and put in my Y values. 495, 477, 425, 322, 482, 587, 370, and 322. I have my values plugged in. Go back to Stat, Calc, Linear Regression number 4, go down to Calculate. Now, you see this extra category. The correlation coefficient is the last one. It's with the R. So, the linear coefficient to the nearest hundredth, so we're looking 3 places. That 2 means that 4 is going to stay the same. So it's going to be R equals 0.94. And explain what it suggests of the problem. Well, 0.94 is really close to 1. So this is a strong positive correlation. Okay, I'm going to stop the video here, and we're going to finish the rest on the next one.